continuous or indeterminate beams. No? Symmetric and unsymmetric, it says. So, what are continuous beams? It says continuous over one or more supports. You have here how many supports? One, two, three, and then you have two beams. No? Uh, they're not continuous, no? But they're not continuous at this support. So the deflection of that would be this. Okay, then this one. Most common in monolithic concrete, still continuous or with moment connections, wood as continuous. Example, long glue lam spans. What is glue lam? Uh, glue lam means they're glued and laminated. Okay. Statically indeterminate, they cannot be solved by three equations of statics alone. Okay, since they are indeterminate systems. Internal forces, shear and moment, as well as reactions, are affected by movement or settlement of the supports. Okay. When you say movement, pwedeng horizontal yan or vertical. Settlement, vertical. Okay. The first method is deflection method. Okay. The conditions here, this is for only for two continuous spans only. No? The loading should be symmetrical and the geometry. Okay. Say for example, we have this beam. No? We have a 24 first span in here is 24 feet. And then 24 feet again from this point up to that point. Okay, continuous siya. So wala siyang cut dito, no? They're not separated at mid span. Okay, how do we do this? Deflection method. We remove the central support. Okay, we calculate the central deflection for each load as load case as a simple span. So if we remove the support here, you have a simple span. You say simple span, you have simply supported beam. Okay. As you can see, we don't account for the horizontal forces here. So horizontal reactions because there are no horizontal forces. So vertical lang tayo. So at the left side, you have a reaction here, and at the right side, you will have a reaction. Now, with this simply supported beam, okay, there's a predetermined formula for deflection. Okay, that's why it is called deflection method. So the formula is 5WL cubed over 384. Now, actually, that's 384 EI. But notice that minove na lang yung EI dito sa harapan. E is the modulus of elasticity of the material of the beam. I is the sectional property. So this is EI delta. EI times the deflection equal to 5W L to the L cubed over 384. Okay. And then it says here, solve the resulting equation for the central reaction force. Okay. Now, that step, it says, still we have a simply supported beam, but this time we will have that support reaction as a load, as a load this time. And then since this is a concentrated load, we will have the equation of the deflection to be PL cubed over 48. So ito predetermined na rin itong formula na to. Okay, later on I will also show how these were determined. Itong mga formula na to. Paano na-determine yan? Yeah. Now, why are we doing this? First, we remove the central support, and then we determine the deflection. Okay, and then we account for the deflection of the support, central support, without uh, the loading. No? So therefore, you also have that equation. Now, in theory, or in the boundary condition, okay, the deflection at that point supposedly is 0. So you will have to set that to 0. Okay. So these two should be equal. Okay. Originally, this is on the right side. Okay. And then transpose this to the left, it becomes this equation. If you add the two, you should get 0. Okay? Na-gets natin yon? So let me illustrate that in a manner na madaling intindihan. So this is our beam. It has 3 supports. We remove this support. Alisin natin yung support sa B. What will happen to your beam? It will deflect this way. Okay? Now, we apply the central support so that what we want to do is to put back, okay, the beam to the position na nandito na siya. 0 na ang ano niya, ang deflection niya. Okay, that's actually what we did here. So this is the magnitude, okay, of the deflection that we put back due to this force. Okay, so parang nag-cancel out yung deflection nila. That's why it's called deflection method. Now let's have an illustration so that you will better understand it. Replace redundant reaction with point load, bringing reaction to deflection to 0. Okay, this is delta deflection due to the load plus deflection due to the reactions or the deflection due to the support. Ito, deflection due to the load, deflection due to the support or reaction. Yeah? Or simply you get the two should be equal. No? Deflection due to the load should be equal to the deflection due to the reactions. Okay, there. With our example, a delta L, okay, let's look back now. You have 3 concentrated loads spaced equally from the left. So this is 15 feet, 15 feet, 15 feet, 15 feet. That's 20 kips. What do we mean by 20 kips? That's 20 kilopounds. No? Kilopounds. Now, perhaps you did not notice this. This one is a uniformly distributed load. Ito na, itong W equal to 1 kip per lineal foot. So 1 kip per lineal foot yan. Okay? This. So you have 3 concentrated loads. First set of loads, second set of load, and uniformly distributed load. Or this one is designated as the first set, and then the 3 concentrated loads are the second set. Now we have predetermined equations of deflection. This is due to the uniformly distributed load. Okay, take note this W here is a small letter. No? And later on, you will see that that can be represented with a capital letter, but that capital letter is the equivalent concentrated load of the uniformly distributed load. But this one is small. Yeah, the one there is the one that was mentioned earlier. So 5WL, L is the length, which is 60. So this is for the uniformly distributed load. And this one is for the three concentrated loads equally spaced. No? So again, if I want to mention that this is predetermined na, given na to. Okay? So you will notice that aside from uh, determining the unknowns, no, by the equations of static equilibrium, we have equations of deflections. Okay? To solve for the redundant, in this case, redundant supports or redundant reactions. Okay, so if we will compute for this, we'll get this, and eventually delta L. If we simplify this, we have this 382,500 over EI. Now that should be equated to the deflection due to the reaction forces, no? Or support reactions. Now, uh, the the equation for the deflection due to the redundant support is this, no? R2L cube. No, in other formula, yung kita nyo rito, P L cube over 48 EI. But we just substitute it right away. What P is being represented, no? P in here is represented by R2 or the central support. Okay? If you will simplify this, plug in the value 60 in here. So you'll get here R2 4,500 EI. Okay? Now, if you equate the two, they should be equal, no? So equate this and this one. Okay, by algebra, you get R2 equal to 85 kips. Okay, will you try doing that? Itong dalawa equate ninyo. So if you equate the two, you'll just cancel EI and EI. So R2 will then be 382,500 divided by 4,500. Okay, if you have a calculator, you can operate that. 382,500 divided by 4,500, you should get 85 kips. Okay, and then you know already the value of R2. We just sum forces along the vertical. Okay, you have R1, R3, and then this is R2. Subtract the equivalent force of the uniformly distributed load. How is that? 60 feet times 1 kip per lineal foot. So that's 60 kips. Sorry. Tama. 60 feet times 1 kip per lineal foot. So that's 60. And then 20 plus 20 plus 20, that's also 60. They're negatives because they're going down. Now, R1 and R3 are just equal, no? Because eventually you'll get here 85 minus 120. That's how much? 35. No? This is minus 35. So transpose that to the right. R1 plus R3 equal to 35. But R1 and R3 are just equal. So that's 2R1 is equal to 35. So R1 is 35 divided by 2. So that's 17.5 kips. So equal sila. Ganun din yung R3. Okay? You get that? And then, so we've determined already, this is R1, This is R2. This is R3. Okay? Which has the highest reaction? Of course, yung R2, no? R2 is 85. Ito maliit lang, 17.5, 17.5. So malaki yung dinadala ng R2. Okay? So you have those forces. Kompleto na. You can assemble your shear and moment diagram. For the shear and moment diagram, you are experts already. So you will skip that. Tama ba? Kayang-kaya nyo na yan. Do I get a thumbs up nung sinabi kong expert na kayo dyan? What's your reaction? Pero laugh out loud dito. React na laugh. Yung iba, anong reaction? Okay? Sandali ah. Stop na tayo doon. The next topic that we're going to discuss is the slope method. And then we proceed to moment, three-moment equation. And then portal and cantilever. Okay? But I mentioned that I will also show you how those equations were derived, no? Yung mga deflection formulas. I'm sure you're a little bit curious, sir. Paano ba nakuha yung mga deflection formulas? I think it's also it's important na you'll have a glance, no? Kung paano ba, how they came up with those equations. Now, I will also include in our discussion yung double integration method. Okay, don't get intimidated of the integration because the integration part is just integration of polynomial equations, no? Yung x to the n. Okay, integral of x to the n dx. Doon lang. Tapos integration by substitution din. I know you've taken that in Math 53 and Math 54. So I don't think you'll have an idea. Papadaanan lang natin how. Okay, next meeting so that you'll get an appreciation of how those equations were arrived at. Paano nakuha. Okay. Now another screenshot. Papa-screenshot ko rin sa inyo so that you can also practice that. Okay, you see it? Yeah. Screenshot niyo siya. So in here you have a beam, but instead of three three concentrated loads, equally spaced, this time you only have two. 20 kips ito, then 15 feet from the left. You still have W equal to 1 kip per linear foot. It's very much the same, almost the same as in our example, but we just removed the concentrated load at midspan. So recompute ninyo. This time you have this equation. Okay. Now, this is the delta max or the maximum deflection at support 2. Okay. Or at the redundant support. In this case, we designate R2 to be our redundant support. Actually, pwede rin namang R3, pero just to make our system, it's symmetrical eh. So it's very much convenient na ito yung gawin nating redundant support. Okay? So for this one, for this formula, A is the distance between the left or right end up to the concentrated load. Okay, that's the value of RA. L is the total length. Okay, so we use this formula. Any question? Sige, na-screenshot nyo na? Yeah, okay, good. Sige. Okay, is it okay to, to stop sharing na? Any question? Sa deflection method, symmetric, anti-symmetric, determinate, indeterminate. Clear naman sa ating lahat yun. Okay. Now, may I request you to open your cameras for our attendance? Ilan na lang tayo? 12 na lang tayo. So you're only 11. Maraming absent ah. Yeah, but you have a class. May si Tin na ganun sa akin. Sabi, I think she's sick. But the rest, okay, sige DJ, it's okay. Kindly remind your classmates na mag-attend sila so that sige. Wala na kayong question? Any question? Malinaw naman? Nasusundan nyo yung discussion natin? Hindi naman kayo galit sa akin? I appreciate yung mga nag-submit din ng pictures and the progress of what they're doing. So kindly just continue your work. And I posted some references. Just go through those references na pinadala ko sa inyo pertaining to best practices of architects in addressing susceptibility to earthquake ng mga structures. Pwedeng yung main structure and then pwede ring non-structural elements. Okay? And then what are the techniques in in addressing yung impacts ng lateral forces, specifically of earthquake. Yeah? Sige. I'll see you on Tuesday. Hindi naman holiday ng Tuesday, no? Let's see anong araw 'yun. That's December 14. Last day of classes is December 22, right? Tama, no? So tayo 21. Wala nang holiday, 14 and then 16 and then 21. We still have 3 meetings. Tentatively, we've set between me and one of your classmates, si Tin. Ang target sana natin 16 yung presentation. Can we make it? We'll make it 21 na. As much as possible, I'll make your grades possible, your standing on the 16th, 1 week from now, para everything is settled before the vacation. And then the next year, yung mga magta-take na lang ng final exam. No. Sana wala na. Our cutoff grade is 78. Kasi yun ang DOS eh. So 78. So 2 pataas, exempted na sa finals. But it's optional. Kung gusto nyo pa rin mag-finals, say gusto niyo pang improve yung grade niyo. Okay? So, I hope I will really try na ma-complete yung standing grade niyo next week, next Thursday. So, we won't skip any days, no? Yung Tuesdays and Thursdays. Okay? So, yung presentation niyo, 15 minutes max so that matapos kayo kagad. So 15 minutes presentation and then 5 minutes question and answer. Okay ba? Okay, kung wala na, edi I'll let you go na. Okay, folks. See you Tuesday. Bye-bye. Thank you.
Thank you, sir.
Thank you.